We learned about C programming, we learned about microcontroller, embedded systems, IoT, and also we learned about Blink app. Now let's see more in detail about these contents. So in C programming, first we learned about the introduction of C programming, and then we learned about data types, modifiers and qualifiers, and next we learned conditionals and loops, operators, arrays, pointers, and also about functions, and also we learned about storage classes and preprocessor. So embedded C programming is used to code in this project. Embedded C is most popular programming language in software field for developing electronic gadgets. Each processor used in electronic system is associated with embedded software. In daily, we use many electronic devices like mobile phone, washing machine, etc. These all devices working based on microcontroller that are programmed by embedded C. Next we will see more in detail about microcontroller. So basically microcontroller is a small computer on a single VLSI integrated chip. So a typical microcontroller contains ADC block, which is analog to digital converter, and also DAC block, which is digital to analog converter, and it also contains timers, counters, processors, memory, and input-output peripherals. So the microcontroller is used to control the functions of embedded system in office machines, home appliances, robots, motor vehicles, etc. A microcontroller is embedded inside a system to control a singular function in a device. It does this by interpreting data it receives from its input-output peripherals using its central processor. The temporary information that microcontroller receives is stored in its data memory, where the processor accesses it and uses instructions stored in its program memory to decipher and apply the incoming data. It then uses its input-output peripherals to communicate and does the appropriate action. Okay, next we will see about the embedded systems. So an embedded system is a combination of computer hardware and software designed for a specific function. Embedded systems are useful in many areas like industrial machines, consumer electronics, agricultural and processing industry devices, cameras, digital watches, etc. Like this, there are so many uses of an embedded system. Embedded systems are often used in sensing and real-time computing in Internet of Things. Embedded system always functions as a part of a complete device. They are low cost, low power consuming small computers that are embedded in other mechanical or electrical systems. Generally, they comprise of a processor, power supply and memory and communication ports. Embedded system use the communication ports to transmit data between the processor and peripheral devices. The processor interprets this data with the help of minimal software stored on the memory. So the embedded system is reliability, cost effective, low power consumption, and it is fast processing. So this is all about embedded system. And next we will see about the Internet of Things. So and this is the main aspect of our project. So the IoT system is a system of interconnected computing devices that are provided with unique identifiers and the ability to transfer data over a network without requiring human to human or human to computer interaction. An IoT ecosystem consists of web-enabled smart devices that use embedded systems such as processors, sensors, and communication hardware to collect, send, and act on data they acquire from their environments. Internet of Things devices share their sensor data they collect by connecting to an IoT gateway or other edge devices where data is sent to cloud to analyze. Sometimes these devices communicate with other related devices and act on the information they get from one another. The devices do most of the work without any human interaction. They do themselves. So this is all about Internet of Things. Next we will see about the Blink app. So Blink app is a new platform that allows us to quickly build interfaces for controlling and monitoring the hardware required for the project. So these are the data streams we need to create for the project. So next, these are the requirements of the project to be done. So we need PixSimLab, which contains Arduino Uno, LDR sensor, LEDs, LCD, temperature sensor, temperature system, Ethernet system, and serial tank. These are all the spare parts of an Arduino Uno board. And regarding to software, we should have Arduino IDE, Blink app, Ethernet, and we must have knowledge in embedded C to code the project. So mainly the aim of the internship is to control the cooler and heater remotely. So remotely means we have to control this heater and cooler using Blink app, and next to control the LED during day and night, which is we all have garden lights in home. So so the aim of this project is to control the garden lights. So we have to off them in the daytime and we have to on in during night time, and also to control the water tank through internet. So this is all about the aim of an internship. So these are the 4 phases of the projects. So phase 1, we have to code the project, and then we have to dump the code into the microcontroller, which is PixSimLab software. And next we use the Blink app to control the Arduino Uno board, and we do the project. So these are the block diagrams of the temperature control block and water tank inlet and outlet value control. So firstly, the Blink app is connected to the Arduino board and it is connected to CLCD and temperature system. So in water inlet and outlet value control block diagram, the Blink IoT app is connected to Arduino Uno and also CLCD and also to the water tank. So this is the interface of the PixSimLab software. This is the Arduino UNO board, which consists of 80 mega 328P microcontroller, and this is the reset button, and this is the USB port. So these are the pins that are present in the Arduino UNO board. So here we can see file, board, microcontroller, modules, tools, and help. Okay, these are the spare parts which are used in the project. Here we have CLCD, here we have LED, and this is a temperature system, and this is Ethernet, this is the LDR sensor. We get these spare parts by clicking on tools. By clicking on modules, we get these spare parts. And this is the serial tank. On the tools, we select the serial tank remote for the project, and we also have to select the serial port as COM5. We implement the project by using Blink app. In Blink app, we create the data streams as virtual pins from 0 to 5. In Blink app, we already set the home automation path, and in that path, we choose the cooler controller and we control using these buttons on and off. After executing the program, we observe the water in the serial tank reach to the maximum level. Outlet is in on position and Vout is stop. When the temperature attains its maximum, then using cooler we decrease the temperature. When the LDL sensor reaches the maximum, then the LED blinks automatically. So this is here is the conclusion of the project. The home automation should be simulated on the PixSimLab simulator. Blink IoT mobile applications used to control the devices should be able to control the lights, temperatures of the home, inflow and outflow of water in the water tank. CLCD acts like a dashboard used for displaying the events. Widgets from Blink IoT app like button widgets are used to control heater, cooler and inlet value, outlet value. Using Blink IoT application and PicSimLab simulator, simulated home automation where a LED temperature system serial tank resembles light, heater, cooler and water tank in real time. Gauss widgets display the temperature and volume of the water. Next we will see here we can see the code that we code for the project. This is the entire code for the home automation project. We can see here. Here we should also download libraries. There are three libraries to execute this code. One is Blink and another one is Liquid Crystal I2C for CLCD display and also U8G These are the three libraries we must download to execute this code. This is the entire code for the project and we can see the code for LDR and this is the main.h code and this is the serial tank code. Here we can see the functions written in this code and also this is the code for temperature system. So this is all about the code. So we will run the code here. We can see here the code is compiling. Yes, the code is compiled successfully without any errors. Next we will export the code to the PicSimLab. We have to select export combined library. Here we can see the code is extracting to the PicSimLab. A hex file will be created. So yes, the hex file is created successfully. Yes, now here we will see the simulation of the project. This is the interface of the PicSimLab software. This is our Arduino Uno board which have 80 mega 328P microcontroller. This is the reset button and these are all the spare parts that are used in the project. This is CLCD display. We can use temperature is showing here. Yes, these are all the spare parts. This is CLCD display which displays the temperature, volume of water in the cereal tank, and this is LED and this is temperature system which have heater, cooler. This is the Ethernet and this is the LDR sensor. So and this is the serial tank. We have to put serial port as COM5. This is the reset button of the Arduino Uno. So yes, the ports are all correct. You can see here. So this is serial tank and these are all the spare parts. And this is the Blink app which is used to control the Arduino Uno board like heater, cooler and serial tank inlet and outlet. Now we will load the hex file, previously created hex file. Now we will load into the PicSimLab. Yes, now we will have all the requirements: serial tank, Blink app, spare parts. Yes, now we will connect the serial tank. we can see that inlet is on and volume of water is increasing in the cereal tank. We can see that volume of water increasing in the LCD display. The inlet flow button is on in blink app. Yes, the water tank reaches its maximum value. When cereal tank reaches its maximum value, the inlet is off automatically. When we on the inlet button, we can see that water is decreasing in cereal tank. Volume of water is decreasing. We can see that in LCD display. Yes, now we will have heater and temperature system. When heater is on, we can see the temperature is increasing. We can observe that in LCD display board. Yes, I think it reaches its maximum value. So when pull controller is on, we can see the temperature is decreasing. And also LDR sensor. During daytime, temperature is high, so the LED is off. So when it reaches its maximum value, we can see that LED will glow. Yes, the LED is glowing, which is during night time. So these are all garden lights. Yes, this is all about the simulation project. Yes, now here we will see the simulation of the project. This is the interface of the PIC SimLab software. This is our Arduino Uno board which have 80 mega